Hello. So, let us continue our discussion on different aspects of this cloud computing paradigm. Right. Today, we will start a discussion on VM migration. So, virtual machine, as all of you know, that it's a one of the major service what a cloud provider provides, right. It is primarily as a in the level of IaaS or infrastructure as a service. So, what you will do, you can have your own virtual machine configured based on ideally configured based on your requirement when you request for the things, right. In reality, what it happens that there are different flavors of the things are available, like different configurations available, like if you have used any open source like OpenStack or any commercial like from Amazon or any other sources. So, you will see that the VMs there are different flavor available, like so different category of virtual machines are there. So, you can basically subscribe that machine for a period of time and then work on that machine and then release when you do not require that machine that VM, right. The challenge is sometimes, so what is happening? There are several servers where the virtual machine are initiated, where the users are using that consumers or the users of the VMs are using this, right. And then there may be a situation like, and suppose there is a server where or a particular server there are say n virtual machine and maybe every server has a capacity of say m number of machines, somewhere in 1, somewhere in 2, in 3 VMs are running, right. And what is happening, like once it is coming, it is getting requisition in one of the VMs, then sometimes once that work is over, there is release, that gap is created and the overall cloud cloud broker so called or the controller units is going to allocate the things. And in this type of scenario, one thing may happen, there may be imbalance in the thing. Some of the servers are loaded heavily, some are less loaded, and so you may ideally need to migrate some of the VMs working in this say server 1 to say server 6, because the server 1 is more loaded, right, or server 3 to server 4 and server 14, anything, right. So, there I require a virtual migration. Secondly, some of the things may require a shutdown that or maintenance may need a maintenance, right. So, once there is a need of maintenance, then also you need to shut down that system. So, all the VMs need to be migrated into the things. So, this migration is a major challenge or is one of the necessity what the virtual what we see in this like when we do any work with this when we think about the data centers or the cloud providers point of view, right. So, in this talk or in a couple of and next talk also we will see that what are the different way this VM migration can occur or what is the basic philosophy behind it. So, we will look at the VM migration basics and the migration strategies, right. So, VM migration. So, what we see that if you see that when we talk, it is a process to move running applications or VMs from one physical server host to another physical server, as we are discussing, right. So, it was running in a host server and then I want to move it to the another server, there may be several needs, we will come to that, right. So, the once a process is running, this is a big challenge. One way of is that you shut down everything, put it to another, switch on the things, right. So, that is possible, that we will see that is one way that is possible, and that may be the easiest way of migrating this type of thing, shut down the process and re-invoke or invoke the process in the other machine or invoke the VM into the other machines, right. But the challenge is that always it may not be possible. The consumer or the user may not allow you that that may not be feasible, because my process is running for days together. I may be running a simulator, or I am running a critical job, and then you say that no, now you shut down. So, that may not be always feasible, right. So, then I am going to do a live migration. When everything is on, then you migrate on the things, right. So, what we try to migrate, that processor state, right, if it is a thing, storage, memory, network connection are moved from one host to another, right. So, processor state, that whatever the storage things are there, memory locations. So, that whatever in the so called RAM, and then the network connectivity, whatever is there, if there are connectivity and it is going away, some network level application is going on, that need to be reconnected there, right. So, this is the type of configuration out here in the machine 1, or the what we say source machine, and the whatever there in the destination machine, there should be a match. There should be that connectivity, because suddenly if there are external connections and doing some network operation, they will be for a spin. So, that is important. Why to migrate? Distribute VM load efficiently across servers in a cloud. That is one of the major one of the reason what we are telling, that load balancing so called. So, one because allocation deallocation of the VMs, what will happen, the some of the server will be more loaded than the others, and then you may want the servers to be more distributed, the loading to be distributed. So, that means distribute the VM loads efficiently across the servers in a cloud environment, right. Another is the system maintenance. I may want to do some maintenance for a server, and in that case I need to migrate those things, right. So, this is that typical picture. I think we that this one of the thing you have we have seen earlier also, or in several literature. So, what is there? The hardware, then the VMM or the hypervisor is there, over where different VMs are there. This is another another server, right. So, I can migrate one to here, right. So, that is the ideally one server one stack of VM is running, and then I want to migrate on the thing, right. There can be either whole everything is migrated, or some of the things migrated there, some other servers and things like that, right. So, nevertheless, this what we see, that virtualization what we have looked studied in earlier means previously. So, I have VMs, then I have virtual machines which have some guest OS, in this case Linux, something NetBSD, Windows, and over that different applications are running, right. Okay. So, if we look into the more deeply in the need of VM migration, one definitely the load balancing, as we discussed, that for fair distribution of workload among computing resources, right. So, there can be several computing resources, and I want to have a fair distribution of the workload of the thing. Maintenance, for server maintenance, VM can be migrated transparently from one server to another, right. So, the server is going for the maintenance, customer is not bothered about it, it wants that SLA to be respected, and its application should be running as smoothly as was there. So, that time because you need to shut down that server where those VMs has to be migrated here. Manage in some cases manage operational parameter to reduce operational parameters like power consumption, VM can be consolidated, minimal number of servers, underutilized server will be put on low power mode, etc. Like I have 5 servers, and maybe in some cases the other way of the looking at the load balancing is that 5 VMs are running in 5 servers, but it could have run in a 1 or 2 servers, right. So, I migrate them to the things, and the other things I put it in a low power mode when the demand is low, right. There may be QoS violation type of scenario, when the service provider fails to meet the desired quality of service, a user can migrate his VM to another service provider. So, this is not only the say one service within a service provider, inter service provider, like one server or one DC to another DC, it is something like one provider to another provider it wants to migrate, right. So, that can be another situation. Fault tolerance, In case of failure, VM can be migrated from one data center to another where they can be executed. So, there can be other fault tolerant type scenario where we need to do some migration when there is, when I am expecting when the system is coming down and there are faults and etc. Right. So, there are various reasons, as you see. One may be for load balancing, maintenance, manage operational, the user wants to be migrated somewhere, and maybe some of the exigencies like or fault tolerant type of scenario. Now, if we look at the migration things, so broadly there are two types, right. One is cold or non-live migration, right. Another is a hot or live migration. So, this is the broad category of VM migration, right. So, one is cold or non-live, another is a hot or live migration. So, what is there in the non-live? In case of cold or cold migration, the VM executing on the source machine is turned off or suspended during the migration process. So, it is during the migration process, the VM is either shut down or turned off, or it is suspended and then it is migrated and then switched on, right. So, in other sense it is a non-live. So, it is not doing the on the fly when the things are running. So, it actually takes a some sort of a quote unquote downtime from the user. They may have to pay some penalty or some cloud credit as a result of that, and that is migrated to the other VM, right. Other one can be hot or live migration, right. In case of hot or live migration, the VM executing the source machine continues to provide the service during the migration process. So, that is the this in case of hot or live. So, it goes on providing when the whole migration process is going on. In fact, the target VM is not suspended during the migration process. So, when it is not suspended, it is a live thing, it is going on. This is pretty tricky. Definitely there are a lot of consideration out here, and but at the same time it gives a somewhat seamless performance for the user, right. So, user practically does not know the migration process is going on. So, it was working and then migrated to the other thing, and its VM remains as the VM things itself, right. So, that can be a hot or live migration. So, what we see that there are two broad categories. One is little simple or easy to conceptualize, easy to implement, that is the cold or non-live migration. Other is hot and live migration is this is a tricky thing and requires a defined process that or how it will execute, right. So, if we look at the live migration, so migrate an entire VM from one physical host to another, all user processes and the kernel state need to be migrated without having to shut down the machine, right. So, what we are doing, the VM from one physical host to another, it is migrated, all user processes which are running in that original VM before migration, and the kernel state need to be preserved or should go on running in the next location without any interruption, and you do not have to shut down the machine per se, right. So, in case of whereas in case of non-live migration, VM providing services remains suspended during the entire migration process, right. Hence, the large size VMs, the service downtime might be very high, right. So, there can be large downtime thing, and there can be penalty for this type of downtime in case of a non-live or cold migration. So, for real time application, non-live migration can cause severe degradation in the service quality, which is not tolerable. So, if there is a real life application like something online broadcasting going on, or some online some computation going on and things like for some real life applications, and then you have a non-live migration, then you have a severe degradation problem. So, two main approaches, one is pre-copy and post-copy approaches are there for this type of migration process, right, this live migration process. So, when to migrate? To remove a physical machine from the service, that is as again and to relieve load on the congested already seen. So, VM migration, if cost wise, the cost associated with the communication overhead, like if you are migrating the whole thing, whole state and other things to the things, there is a communication overhead, and cost associated with the migration time, downtime. So, this is the costing on the things, right, how much migration time, how much time downtime, and then effectively affects the overall performance of the cloud, and at times it may violate the SLA, for which the CSP has to pay for it, pay the penalty for it, right. And also it hits its if lot of downtime and my times are there, then it also hits its reputation, right. So, so these are different typical factors what we intuitively also try to know. So, based on that, so the major concern are the minimize the downtime, right, definitely minimize the downtime. Downtime refers to a total amount of time services the services remain unavailable to the user. So, downtime, what we say that overall time so long the services are unavailable to the user, that is the what we refer to as downtime. Minimizing the downtime is one of the major challenge. Minimize total migration time, right. So, migration time refers to the total time taken to move a VM from the source host to the destination host, right. So, I have a VM running, right, and then the whole VM is migrated to the another host, another server, and it is running faithfully. So, nothing is left behind, means like no memory, no state and other things, right. So, the total time requires whether you want to shut down and revoke or do it dive migration, etc., that is the migration time. So, it can be considered as the total time taken for the entire migration process, right. So, that is why minimum the migration time, better your performance, because migration is always a overhead over the whole system. So, migration does not necessarily disrupt the active services through resource contention, that is CPU, network bandwidth with migrating ways, right. So, what it tries to do that there can be resource contention, CPU, network bandwidth, etc., where you are at the destination, source and destination, that need to be taken care of. So, now what to migrate, as we started the discussion with, one is the CPU context of the VM, like contents of the main memory, these are the two things need to be migrated, because as if you as we have shown the figure. So, it was running on a hypervisor, right. So, and it has a this CPU context of that particular VM, and the contents of the main memory of the things has to be migrated, because now it is be running on another hypervisor 2, and those has to be instantiated. Disk. So, if there is a network attached storage that is accessible from the both hosts, so that is one way of handling. So, both hosts can connect to that particular NAS storage, right, or NAS server, that is accessible both hosts, or local disk is mirrored. Migrating disk data may not be critical. So, if it is on a NAS server, so this disk data is still, you just need to reconnect. Now, the connection is from this particular port or this server, and now it is from the other port, that may not be very challenging, right, but still there are nitty-gritty is there. Network, assume both the host on the same LAN. So, if you assume both the host of the same, migrate the IP, advertise new MAC address to the IP mapping via ARP reply and all those things, right. So, if it is much easier, or if it is on the same LAN, or I need to do other things like proxying and other things has to be there. So, migrate MAC address, let switches learn new MAC locations, network packets redirected to new location with transient losses, and all those things will be there, right. So, there are challenges, but there are ways out, in a sense that if it is within the same service provider, they can extend the LAN and things like that can be possible, right. But nevertheless, network is a issue to be looked into. Then IO devices, virtual IO devices are easier to migrate if it is a virtual. Direct device assignment to physical devices VMs may be difficult to means physical devices to the VMs may be difficult to migrate. So, that can be a if there are virtual devices, then it is easier to migrate, but if there are direct devices attached or means device assignment of physical devices to the VMs, which may be difficult to migrate. Then you have to take care of that, how this connectivity will be there, even it because the physical device needs to now connect it to the other things, right. So, if we look at the memory migration steps, so one is that push, source VM continues running while certain pages are pushed across the network to the new destination, right. To ensure consistency, pages modified during the process are resent. So, what will happen? The source VM is running, along with that the this memory pages are pushed to the destination while the source is running. So, whatever is getting modified out here or dated, so that has to be retransmitted, right. So, go on retransmitted. So, stop and copy, source VM stopped, pages are copied across to the destination VM, then the new VM start, right. So, this is one thing. So, you push it, then stop and copy and then pull. New VM executes, and if it accesses a page that is not found in the copied, the page is faulted in the pulled across the network from the source. So, that means there can be push, there can be stop and copy, or pulled when the source is running, when the destination VM or the migrated VM is running, if it does not find some page, then it can be pulled across the network from the source VM, right. So, that is say when the live migration is going on. So, pure stop and copy simple, but both downtime and total migration time are proportional to the amount of physical memory located in the thing. So, pure stop and copy means you just stop, copy and then do. Then what will happen that how much migration time is dependent on the amount of physical memory allocated to the VM. May lead to an unacceptable outage if the VM is running via live services, right. So, if it is a something which is live services is running, then this outage may be may not be acceptable to the consumer or the user, right. So, this need to be taken care. So, if the live some services is providing, then this type of things becomes a serious challenge. Pre-copy phase, it is carried out over several rounds, right. When we have a pre-copy phase, the VM continues to execute at source while the memory is copied on the destination. So, this is the pre-copy phase, right. So, it continues in the source and then go on copying to the continues to execute the source while the memory is copied to the destination, right. Pre-copy termination phase. So, when should I stop, because if it is running, then some pages are getting modified and things like that. And so, the stopping criteria for the pre-copy phase takes one of the following thresholds, like the number of rounds executed threshold. So, I say that there will be n rounds and it is over. Total memory transmitted exceeds the threshold, like how much memory can be transmitted over the things, it is above a threshold, or the number of dirty pages in the previous round drops below a threshold, right. So, when I am basically any modification, then only I need to transmit. If there is no modification, then I do not may need to transmit that to the destination, right. So, when the number of dirty pages is below a threshold, then I can stop. So, some of the stopping criteria. And stop and copy phase, in this phase execution of the VM to be migrated is suspended at the source, then the remaining dirty pages, the state of the CPU is copied to the destination host, where the execution of the VM is, then the execution of the VM is resumed. So, what happened, the execution of the VM to be migrated is suspended at the source. So, it is suspended source, then the remaining dirty pages CPU state are copied to the destination, and while then the execution of the is resumed at the destination, right. So, that type of those that is the stop and copy phase. So, iterative pre-copy live migration, in case of iterative pre-copy this phase may be carried out over several rounds as we were discussing. The VM continues to execute at the source while its memory is copied to the destination. Active pages of the VM to be migrated are copied iteratively at each round. During the copying process, some active pages might be dirtied, like there may be change in the things as we discussed at the source host, which are again resent to the subsequent round to the things, right. If there is a update of the things, so that page to be terminated. Pre-copy termination, or we already discussed that either the rounds are this total, this is basically it is more the same thing what we discussed in a more organized way. And other total memory transmitted exceeded threshold, or what we see the number of dirty pages in the previous round drops below a threshold, those can be there. And stop copy already we discussed, and there is a restarting phase, the restart the VM at the destination server. So, what we see when we try to do a live migration, this is a very pretty complex process, and also what we are not looking at, that what we are considering, that the network delay is minimal, right. So, because if it is a far away migrating from one data center to another center, there will be a serious challenge, that the delay in the overall communication path, right. So, these are the things what we look at. And post copy live migration. So, what we did, the stop phase, stop the source VM and copy the CPU state to the destination VM, right. Restart the destination VM. On demand copying the VM according to the demand. So, the on copying VM memory, right. So, on demand means, as we discussed in the pool, like there is a in the destination there is a, it found that one some page is not found, then it is pulled, or on demand it is copied from the source things. So, in the post copy strategy, when the VM is restarted, the VM memory is empty. If the VM tries to access the memory page that has not been copied, the memory page needs to be brought from the source VM. However, most of the time some memory pages will not be used. So, we need only a copy of the VM according to the demand. So, that means it is not like that all are need to be copied. So, in reality what will happen, you have that things which are there, and whatever is on demand you are basically migrating those. So, with this let us conclude our today's discussion, and we will continue this migration things in our next subsequent talk. And there are some of these nice references, you can have a look into the things, right, on VM, primarily on VM migration, mostly more critical on the live migration of the VMs, right. With this let us stop our today's discussion. Thank you.